All right, we're expanding our solving equations to some more multi-step and when we have variables on both sides. So for the most part, today we are going to be reviewing just what happens with the variables on both sides. So because of the variable on both sides, it actually gives us brand new types of answers. So there's one solution, the thing that we've been pretty much solving most of the time in our mathematical careers. You solve an equation, you have x either on the left or the right, and it's equal to some number a. We have one solution. X is this number right here. But it's also possible now for there to be two more. No solution and all solution, also known as infinitely many solutions. You may see it two different ways depending on what kind of text you're looking at. So no solution, what happens is there's no variable present in the end. So we go through, we solve the entire equation, we get something like 3x plus 4 is equal to 3x plus 5. We get rid of these x's on each side, and we're just left with this 4 is equal to 5. Well, 4 never equals 5. There's no variable, there's no x, no y, no letter at all. When you see something like this, we have no solution. In a very, very similar way, an infinitely many solution, you get something like this. 3x plus 1 is equal to 3x plus 1. And if we don't immediately recognize that this is the exact same thing on the left and right, and we get rid of the 3x's on each side, and we get 1 is equal to 1, well, that's always true. That's why it's called an all solution. No x still, no variable. There's every number for x is a potential answer. No matter how hard we try, here we'd have a no solution. No matter how hard we try, we'd have an infinitely many here. So if we have a both sides equation here, the first thing we want to do is make sure that each side is as simple as possible. Once we've done that, we want to get rid of one of these variables. I always like to get rid of the smallest number that's next to x. So 2 is the smaller one. I'm going to subtract 2x from here, subtract 2x from there. These go away. I'm left with a negative 5 is equal to 1x, or just x for short. Now all we do is we solve this equation like we've solved all the other ones. We subtract 8 from both sides. We get negative 13 is equal to x. Another one. Usually, even if this was, let's say this happened to be like a 3x on this side, I didn't know what I just said, and it was like, let's move the 3x. Well, what we're trying to do is we're trying to get x's on one side, numbers on the other. So in this problem, I'd actually get rid of the 5x. No, it goes against what I said, getting rid of the smallest x. But what I'm trying to do is get, again, x's on one side, numbers on the other. I'm left with 15 is equal to negative 2x. I'm going to get a fraction answer, which is fine. I divide by negative 2 on each side. And so here are all the potential answers that you are welcome to write. Very simply, negative 15 halves. Can't be simplified in any way in its current form. If you want to move it to a mixed fraction, I would say don't do that. Don't do a mixed fraction unless we're talking about a word problem and we're trying to give units for it. If we did it as a mixed fraction, 2 goes into 15 7 times with a remainder of 1, so it would be negative 7 and 1/2. You could, if you wanted to, even put it as a decimal. But again, why do all that extra work when you could just leave it like this? All right, skip one. Let's make it a little bit more challenging. So like I said, before you even try to do anything, you're looking at this problem, you're like, all right, I'm going to subtract the 8x from the 11. I'm like, no. Before you do that, get this side simpler. On this side, I can put the 4x and the 11x together and get 15x minus 7. Check this side. I can put the 23 and the negative 9 together, so I still have the 8x. And 23 and the negative 9 gives me 14. Now that everything is simpler, Now I'm going to worry about moving x's from one side to the other. I don't do that until everything is simple. I'm going to subtract the 8x. It's the smaller value. It's going to make my life easier almost all the time. So I subtract the 8x. That gives me 7x minus 7 is equal to 14. I add 7. I get 7x left over equals 21. Divide by 7, and x is 3. So again, I made everything simpler, then moved x, and then I solved the equation that I had. So let's throw in some distributive property as well. This left side is already simple, so we're good. I'm going to distribute the 5. So I still have the 2m plus 5. I have the 5m minus 35 minus 3m. I combine my like terms, so I get 2m plus 5 equals 2m minus 35. I subtract 2m from both sides, and I get 5 is equal to negative 35. I notice right there, that's not true. We have a no solution. One last one for this. Let's do this one with the fractions. So before I do anything, I'm going to look at my denominators, and I see that my denominators, the first number that they all go into is 8. So if I want to get rid of all these fractions, I'm just going to multiply this entire thing by 8. Now this is like a very large distributive property. 8 here cancels out, so I'm just left with 3. 8 times 1/4, it actually gives us negative 2n. 8 times 1/2 gives us 4n. 8 times 3/4 gives us negative 6. I divide by the bottom, multiply by the top. And now I just can solve my equation. I'm going to add 2n to both sides. Oops. There we go. That gives me 3 is equal to 6n minus 6. Add 6 to both sides. It gives me 9 equals 6n. Divide both by 6. So n equals 9/6. Or, the computer's running a little slow right now. We simplify that, 3 goes into both, 3/2.